All right, I think we've got a good enough starting crowd, Casper, to get the party started. So hi, everybody. My name is Mia Brondum. I'm coming to you today from San Jose, California. It's a pleasure to be with you on a live webinar. I am excited for today. I've got my colleague Casper with me today to host this webinar about automated and manual window control for natural ventilation design. So thank you so much for those of you joining us live today. I know it takes a lot to take yourself out of that break, Zoom tired, virtual tired, whatever it is. But we're so happy that you are willing to spend some time with us to talk about this topic, automated and manual window control for natural ventilation design. So let's go ahead and get started. Just some housekeeping rules. So duration today, we've got 45 minutes approximate for a webinar, then we've got some time for Q&A. Tips and tricks to get your audio and bandwidth at best capability, try to be plugged in. It all seems that we all know all these IT tips and tricks, but always good to get a little reminder. If you've got tons of browsers on, try to click those out just to have yourself the best experience possible for our live webinar today. Questions, as you guys are already kind of trickling in and saying hello on the chat. I love that. Please keep asking any questions that you have on the chat. And I will keep an eye on it as Casper kind of presents some of the topics at hand for today. We will have dedicated Q&A time at the end, but if I feel that some of the questions are also really important to address while Casper's speaking, maybe I'll interrupt and just try to interject some of the Q&A as well. We are trying to have this to be as dynamic as possible, because there is nothing worse than just seeing a ton of slides and it being monotone. We've also got some great interactive dynamic activity. So we hope that you guys will participate in some polls with us today. But if we do not get to answer your question that you've posted in the chat, either throughout the webinar or at the end of the webinar in the Q&A section, because we are out of time, then do not fret. We will make sure to send you an email to address your question directly so that you get an answer directly from us as well. We've got this webinar is being recorded. So you will get a recording of the webinar after you maybe have watched it live, or it'll come to your email if you're watching us on a recorded basis. This should be coming to you about an hour after the webinar and will be sent directly to your email. If you have not received the recording of the webinar by tomorrow to your email, please send me an email. There's going to be two opportunities that you'll see my email, and I'll also write it in the chat. But if you have not received the recording by tomorrow, please send me an email and I'll make sure that we get you access to that. Maybe there's some issues with the registration. But yeah, so who are we? Thanks for joining us. I am Mia Brondum. I am the sales director for WindowMaster Clearline Incorporated, which is our North American sales subsidiary of WindowMaster International. As I said, I'm based West Coast time, so I'm in Northern California, coming to you from the West Coast. Today, I've got my colleague Casper joining us. He is coming from our headquarters. So Casper is part of our building performance engineering team, which is a team that we actually have in-house at WindowMaster to help with all building performance related topics, questions, analysis, etc. And Casper has got some really interesting material and studies to show you and reference cases to talk about regarding our topic today with manual and automated window control for natural ventilation design. So Casper, I'm super excited to have you join me today. Here is Casper and I's contact information. Do not hesitate to email us if you have questions. Maybe that pop up at a later time. Connect with us on LinkedIn. There's also my phone number here. Give me a call if you'd like to discuss something over a call instead. Connect with us in what way works best with you. So with that said, Casper, I am going to hand it over to you. There we go.
Thank you, Mia. And again, thank you everyone for joining today. I'm looking forward to talk about manual and automated windows in relation to natural ventilation. And first off, I want to have a brief talk about the term natural ventilation, because it is something that we really see gets more attractive in green, sustainable, low energy buildings. However, the term natural ventilation is really covering a lot of different levels of system design. So everything from simply having manual operable windows to a more automated, integrated system within the building. And these levels of designs make a big difference, and it is really depending on, of course, the use of the building, the need of the occupants, but also what the ambition and goal is from the designer's point of view. So is it to have these operable window to be an integrated part of the ventilation, or is it more a thermal comfort feature to provide the occupants with some personal control, more similar to ceiling fans, for example? You could maybe call this even natural conditioning. And this is really the origin of this webinar, I think, to discuss these different levels of design. And Mia and I would actually like to start off with a quick poll. So I will already give the word back to Mia.
All right, guys, I've got a poll for you here. So the first poll that I'm going to start has to do with what drives or has driven you to include natural ventilation design in your project. Please give us your answer. I should have posted the poll now. And please start providing some answers. I've got a few different options for you on the screen. Please write to me if you cannot see that's popping up for you guys. Awesome. We've got some polls coming in. So again, what drives you or has driven you to include natural ventilation in your design project? First one, option, client wanted a fresh way to bring in air. There was maybe some potential energy savings, increased sustainability profile for the project, strategy to increase health and wellness in the space, or maybe it's all of the above, or maybe you haven't worked in a natural ventilation project before. That is okay. Just trying to gauge what some of the drivers out there for you guys have been or are for the use of natural ventilation in a project. And just remember, that can be on a manual sense, that can be on an automated sense. However the design is, what we are talking about today is just in general using natural ventilation. What has driven you to include that, or right now if you're potentially working on a project. So please submit your answers. I see you guys are working on it. Appreciate your interaction. And I'll just give it another 10 seconds and then I'll close it up and show you guys what the answers are looking like. All right, I'm going to go ahead and close that poll for now, and let's take a look at what our answers were from you guys. All right, so most of you said actually it was all of the above. So the second to that was the client wanted a way to bring in some fresh air. Nobody said anything about energy savings, nothing about the sustainability profile of the project. Some had also given some feedback about, well, it was maybe discussed also as an increase in the health and wellness, or again, all of them combined, I guess, is the highest feedback that we have. And then a few of you have never worked on a natural ventilation project. Fantastic. Thank you for showing up here today and learning about this topic. Maybe it'll come in a future project for you. So interesting, Casper. Let's bring that with us for the rest of the webinar. It's a little bit of everything, a little mix of everything.
Yeah, looks good. So with that said, let's take a brief look at the agenda today. To begin with, we want to look at some of the benefits and pitfalls of operable windows. Then we will address a quick study about occupant behavior in relation to manually operable windows. Then we will take a look at some system design and how automated control differs from manually operable windows in relation to hardware, sequences of operation, and different ventilation strategies. Then we will have a case study showing point 3. And finally, we will have a brief talk about some of the general struggles that designers experience when trying to implement the operable windows in energy modeling software. Just to mention, we use some data in the webinar today from various studies, and some of the primary studies that I will encourage you to take a look at after the webinar is listed on this slide. And of course, this is recorded, so you can always go back and look at these references. Now, one of the greatest benefits of operable windows in general is this level of personal control that you provide the occupants that you can't have in the same way with manual ventilation or mechanical ventilation. Different studies show that there is a clear connection between naturally ventilated buildings with operable windows and the level of personal control experienced. Now, this is something that we know really increase user satisfaction, but it's also something we have seen will allow the occupants to accept a wider range of temperatures, which is something that allows us to be more ambitious with our design and maybe even use something as the adaptive comfort model, which really is where personal control is a requirement. Now, when we introduce automation into the building, it's of course important to make sure that the systems doesn't interfere negatively with this personal control. And there's not really any perfect answer for this, but there is different things you can do to prevent this interference. For example, it's important to balance when you have an automated system when the system will regain control after a manual input, because if this is too fast, then the user can feel that the building is counteracting their input. You can also make a more practical solution where you have separate windows, for example, for automated control and manual control. And I will show an example of this later. Now, one of the greatest both benefits and pitfalls, you can say, with operable windows is this correct window position in relation to having the correct airflow, bringing in the sufficient amount of air, but without causing any problems inside the building. With more simple automated sequences and with manual control, we tend to be very cautious in relation to the outdoor temperature in which the system will operate within. However, we know that in modern buildings, for example, passive houses, there is often a cooling demand even at lower outdoor temperatures because of the air tightness and the insulation level and all the heat produced inside the building. So in order to really take advantage of the free cooling potential and ventilation potential, it requires us to have a good control of the window position, which is very hard to achieve with manual windows and can be achieved with automation if the sequences is sufficient. This I will also talk about a bit later. Now, studies also shown that there is a great benefit of having access to the natural environment within the built environment. This is not limited to natural ventilation, but also in relation to daylighting, of course, and window view. which is why we always suggest that buildings are designed with the focus of bringing the occupants closer to the outer perimeter of the building. If we look more specifically at natural ventilation, the studies show that we can reduce the sick building syndromes, the occurrence of sick building syndromes inside the built environment. And this term is covering all of the common negative effects that you can experience inside the built environment, such as headaches and different kinds of irritation and concentration problems. The studies show there are many different studies on this topic. The ones I have on this slide shows an approximate reduction of this syndrome of 45%. And it's important to mention that these syndromes are something that really needs to be prevented and not reacted to, because as you know, once you have a headache and once you feel tired, it's very hard to kind of fix that. So it needs to be handled before the occupants experience this. And this is where we need often more sensitive equipment, such as CO2 sensors, for example, to help us with this. And it is very beneficial to have it in connection with an automated system and not rely on occupant control to prevent bad air quality. Last things I want to mention in relation to the pitfalls is the noise production by having automated windows, which in the past has been a big concern, and it is really a result of outdated and bad hardware. With modern hardware in buildings, we always suggest that they have at least 3 different operation speeds, the actuators controlling the windows, of course, and this is because the operation speed is directly related to the noise production. Here we have some measurements from one of our actuators where you can see the operation speed and the noise produced. The first operation speed that we suggest is for an automated mode. Of course, that's the most important, I would say, to make sure that in an automated mode, it doesn't cause any issues for the occupants. And later on, I will show an example of how many times the windows can actually operate throughout a day to emphasize the importance of this. On the other part of the side of the spectrum, you have the need of a more fast operation speed in, you can say, emergency mode. This could be something as rain, where you don't necessarily are concerned about the noise produced, but you want the windows to close very quickly. The last operation speed that we suggest is for manual mode. Even in an automated system, this is still important. And this is somewhere in between the automated and the emergency mode. Why this is important is because in manual mode, especially if the windows are not in your line of sight, it's important to have some kind of audible feedback when you operate the windows. It can also be that the occupants want to close or open the windows faster than what's possible in automated mode, based on unexpected noise outside or an unpleasant smell within the building. This brings us to the next poll that we want to present. So I will give the word back to Mia again.
Casper, also before we go to that, Vanessa had a question about, are these speeds dependent on what style of window? So dependent on the window configuration, I guess a hopper versus awning versus casement versus parallel pop-outs, inward, but also versus outward projecting. Are those speeds dependent on the style of the window?
I would say in the general answer would be no. In general, in automated mode, you want the windows to operate pretty slowly to not produce any noise. And it's not really important whether they open very quickly or not. You can say maybe with skylights that are far out of reach or out of where the occupants can't hear them, then they can maybe operate faster, but general answer, no.
Yeah, so no matter if it's a hopper or casement or an awning inward, outward, or projecting, in general sense, it shouldn't have an impact on the style of the window. Vanessa, it's important that you connect with your actuator provider and talk to them about the decibel levels of the various speeds of that actuator that you're looking to use in a project. So most actuator providers will show, or at least can give some indication of what the decibel levels of their actuators are, and if they also have the capability to do the varying speeds dependent on how the actuator is used, as Casper said, automated mode, manual mode, or the emergency mode. So important conversation to have to also make sure what kind of actuator you're specifying will work with the project that you're working on. So everybody, I have got a poll for you as well. Thank you for the question, Vanessa. I'm going to show another poll here, and this poll has got to do, it says, what type of natural ventilation have you worked on in the past, or are you working on in a project now? Not the same question as I had before, but it's what type of design are you using? So as you'll see popping up here, there should be some different options for you. So have you or are you working on a natural ventilation design type in a project where you're only using manual windows? So this would be going up and manually opening and closing a window with a hand. Second option is automated, but only with the touch of a switch. So here I'm meaning like an occupant switch that's either mounted on a wall or some kind of remote control. Only with the occupant having to go up and make the choice to actually do the opening of the automated window. The third option is from sensor-based control only, so a natural ventilation design where sensors are controlling the automated windows only, no occupant integration or interaction at all. And then the fourth one is a mix of the two. So both allowing a natural ventilation design where it allows sensor readings to be integrated, but also where the switch, so the occupant control is included as well. So both of them. And then last option is I haven't worked in a natural ventilation project or are working on one. So no feedback to this poll question at all. So please submit your answers. Give you guys another 10 seconds. I love the interaction. Love to see that you guys are participating in the poll. Thank you so much. All right, let's have a close of that and see what the answers are, Casper. So we've got the majority actually here saying that it's both with a switch and with a sensor reading. Sorry that's cut off there, but this the highest feedback answer is with the use of both sensor and occupant override control, which is really interesting to see. Second one is just manual windows, so no automation whatsoever. So you've worked or are working on projects only where manual windows are included. And then there is a tie between only a switch or have not worked on any natural ventilation in the past or currently. So very interesting, Casper. The highest one is both with the occupant control and the sensor readings for the design of a natural ventilation system. Thank you so much for submitting and participating in that. I'm going to remove, and then I will give the word back to Casper.
Yes, thank you. So now I want to present a quick study on occupant behavior in relation to these manual windows. This was performed by UC Berkeley in California, and the study was based on 16 different buildings throughout the US, most of them on the West Coast. It was also based on occupant surveys and featured this signal application telling the occupants when to open and close the windows. The first results from this study I want to look at is the response to the open and close signal. Here the participants had the option of answering always, usually, sometimes, never, or not aware in response to whether they responded to the open signal. Initially, we can see that the results vary a lot. There are no direct connection between the number of occupants within the building and the response. The best three cases you can see here in terms of response was also the building where the occupants received the most training or education on the system, and where they were actually actively reminded on using the system. We can see that in the best cases, the three best cases here, the number of occupants that frequently responded to the signal which means they answered usually or always, was about 50%. And in the other cases, this number of occupants were only about 20% approximately, where the majority was answering that they sometimes responded or never or not aware. If we look at the closed signal, it's approximately the same trend, but here there is a little bit higher in some of the cases response in terms of frequent use of the signals. We can see that there is a large part that answered not aware, and this is a common problem, you can say, with systems that rely on occupant behavior. And it brings us back to the initial point in the intro in terms of the aim and goal with the system. So you can say if the goal is to provide a feature for personal control and thermal comfort, then the results here can be okay. But if it is meant to be a more integrated part of the ventilation system, I would say you should definitely question whether it is feasible to rely on occupant behavior only to regulate the ventilation through the operable windows. The next result from this study was where the occupants were asked their motivation for opening the windows, so whether they want to be cooler or get fresh air, and their willingness to follow the signals, or if they were more inclined to follow their own preferences. And what we can see here is that the results also varies a lot between the extremes. In the case of the willingness to follow the signal, there was actually a large connection between the number of occupants and the willingness. And this is probably a result of an open office environment where the occupants feel more responsible in terms of the indoor environment towards their fellow occupants. The motivation behind opening the windows was mainly based on thermal comfort or to get fresh air. And the fresh air answer is pretty interesting because behavioral models when it comes to operable window control is mainly based on temperatures, because these are easier to predict in terms of occupant behavior. As we talked about before, the humans are not doesn't have the greatest ability to sense bad indoor environment or bad air quality. The main reason for not responding to the signal or not opening the windows was primarily just not paying attention to the system, so being occupied with other tasks, again, which is in general a problem with these occupant relying systems. From the building operator's point of view, the most important thing was, of course, that these windows were closed when the employees left the office after hours. With that said, let's take a look at a ventilation solution and how an automated system really diverge from manually operable windows in terms of the hardware needed. Of course, with both options, we need openings toward the outside to bring air in, but we also need to prioritize indoor vents if there is connected spaces where we need cross ventilation, for example, an office connected to an atrium. These operable windows can be operated by actuators, which can be connected to a central motor controller. And this is, of course, necessary in an automated system, but it is also often used for manual control. If, for example, the windows are too heavy to be operated, if they are not in reach of the occupants, or if you want more efficiency in terms of opening and closing multiple windows at the same time, this can also be beneficial for the building operator in terms of the security of the building. Now, with automated control, the motor controllers can also receive input from sensors, of course, inside the ventilated spaces and use this to operate the windows. In an automated system, the motor controller can also be connected to a BMS, a building management system, to gain further input from, for example, a weather station, and this can provide outdoor temperature and outdoor wind conditions such as wind speed and wind direction. Solar shading is not directly a part of a natural ventilation system, but it is still very important to consider and making sure that when the windows open, they don't interfere with the solar shading, but also to make sure that when the solar shading is activated, you can still provide fresh air into the occupied spaces. When we look at hardware needed for an automated system, it is really not that much more than for a manual option, especially if you already have the actuators and the motor controllers for the manual system. Where the automated system really differs from the manual option is when we start to look at the operation sequences. And this is where we can become more ambitious with the system if we are able to control the window position more accurately, as we talked about in the beginning of the webinar in terms of the outdoor temperature. This will, of course, require some more input from the engineers and shift a lot of the responsibility on the engineers, where you can say for a manual operable system, the risk and the responsibility is moved more on the occupants because they are responsible for opening and closing the windows based on the indoor environment. But we really have, if we want to be more ambitious with when we can use the system, it is worth taking more responsibility of the system and including different factors such as temperature, CO2, and so on in the window operation, and especially wind speed and the wind conditions are important when trying to figure out the right window position in terms of the airflow in the building. So it's important to know whether the windows are sheltered or exposed to the wind. On top of this, these sequences, we also have different ventilation strategies that we can use in an automated system. For example, pulse ventilation, which is mainly used or is a great benefit for colder conditions, or to provide a more dynamic indoor environment for the occupants. Because here we don't supply a steady state airflow or steady airflow to the occupied zone, but we use the windows to provide a more dynamic airflow into the occupied space. Then we also have trickle ventilation, which is again about finding the correct window position in relation to the necessary airflow based on the indoor environment, so we don't just open the windows randomly. The last strategy is night cooling, which is where you reduce the temperature inside the built environment during the night to cool down the building mass and other materials inside the building. And this is not limited to natural ventilation. However, it is a great benefit with operable windows, because not only is the airflow free of any energy consumption, but you can also often have a really effective night cooling compared to a mechanical system where the maximum capacity is primarily based on the daily demand from the indoor environment and cannot necessarily be exceeded. Whereas with operable windows, you can often achieve a much higher airflow during the night because there is a greater temperature difference between the inside and the outside. So you have more passive driving forces and can really achieve a very effective night cooling. A quick case study showing these strategies. Here we have an example with small high-level windows for automated control. We have larger windows which are purely manually controlled. This was what I talked about personal control in the beginning, that these windows are not being interfered with by the system. The design here is based on cross ventilation, so you have the same setup on the other side, and you have a very heavy building mass with exposed concrete, which is optimal for night cooling. The system is controlled based on the factors that we talked about and the strategies presented before. First off, I want to show a window operation during a week in the winter season. So this is in the beginning of November, where you can see the average window position in the zone, and you can see the CO2 concentration throughout the week. Now this slide is really showing how often windows can operate throughout a week in an automated strategy. And as you can see, the windows are often opening to a maximum position, and this is because of the size of the windows, where if the windows would have been larger, we would not see them opening to the same degree. But this is also why these small windows are so effective for an automated control, because you really reduce the risk in the system. So even when they open fully, it is limited how much air you can supply to the space at a given time. You can see here that on a day with lower CO2 concentration, the windows will naturally operate less than on a day with a high CO2 concentration. If we look at a daily basis here, you can see the strategies I talked about before. You can also see we have these scheduled pulses here, which are basically similar to background ventilation, so they operate independent of the temperature and CO2 in the spaces. We have, for example, a scheduled pulse also here right before the occupants arrive to the office to make sure that there's fresh air in the morning. When CO2 starts to rise, you can see very clearly that the set point for the pulse ventilation is 600 ppm. This could be different in another project, but here it's 600 ppm, and the pulse ventilation will be activated. The following hours, the CO2 concentration will still rise within the space, and when the system realizes that it isn't maintaining the CO2 concentration, it will activate the trickle ventilation in addition to the pulse. This could also be the other way around, where you activate the trickle ventilation first, but in this case you have preferred or prioritized the pulse to create this more dynamic indoor environment. We can actually also see, or just to mention, when this trickle ventilation, of course, means that instead of closing entirely between each pulse, it will return to a minimum position where air is still supplied to the space. And if we go back to the weekly basis, you can actually see here, if you look closely, how the trickle ventilation will also respond to the CO2 concentration inside the space. So this minimum position, where a day with a little bit lower CO2 concentration, you have less trickle ventilation compared to a day with high CO2 concentration, and you have a larger minimum position between the pulses. These two strategies combined will then maintain the CO2 level the rest of the day until the occupants leave the office. And as you can imagine, this kind of strategy here is not really feasible with manual control. Otherwise, you would almost have to hire a person purely to operate the windows. In the summertime, we have the night cooling strategy, as I talked about before. And with effective night cooling, we can actually see how the potential of natural ventilation can be extended. Here we can see a week in August, so in the summer season, and you can see the indoor and the outdoor temperature of the spaces, where the light color here is the indoor. So you can see that even though the outdoor temperature exceeds 80 degrees Fahrenheit and even exceeds in some cases 85, the indoor temperature is still staying at a much lower level and a much more acceptable temperature range. And this is really the effect of the night cooling used in the building. This also, of course, requires that we don't supply an excessive amount of fresh or hot air, as the outdoor temperature is much higher than the indoor temperature. And this is why we can use some of the strategies from the winter time, so pulse and trickle ventilation again, to only supply the necessary amount of air to regulate the air quality. This is a case here, House Zero. I just wanted to show another case. This is a project on Howard campus in Boston, where they take some of these strategies to an even more advanced extent and use natural ventilation throughout the entire year. And to do so, they have 4 different operation modes based on the season, the outdoor temperature, and humidity levels. And I know Mia has attached a brochure for this project, and you're also very welcome to contact us after the webinar if you want to know more about this operation. They have already also released a report on the operation so far on this building.
I also put a link to the chat there on more details about the case study. It's found on our website too. So check the chat if you'd like to read more about the house serial case study that uses all the natural ventilation design strategies that Casper was talking about.
Yes. So yeah, I can see we're a little bit tight on time now, so I will be quick on the last slide here. This is just a brief talk about some of the struggles when implementing these operable windows in energy modeling. And it's going to be very high level because it's an entire webinar topic in itself. But we see that the use of natural ventilation is really driven in many cases by low energy design. So it is really there is really a demand for having models, for having good models for energy modeling purposes. And with automated control, of course, you can treat it as a mechanical system. It's easier to predict how much we can use the system throughout the year. I have an example here. For example, for Boston, in a building based on certain criteria and so on, to investigate the amount of hours where you can use the natural ventilation throughout the year. With the automated system, the challenge, of course, begins with the operation sequences and how you can replicate this in the modeling software, and it varies a lot how the modeling software is able to implement natural ventilation, because the sequences is a little bit more, or depends on more factors than for a standard mechanical system. For example, for the wind condition, it's typically challenging to implement this in modeling software, especially when you start to have to take the surroundings of the project into account. We have a written guide on some suggestions in relation to how you can implement the operable windows and some operation sequences, which I think is also attached here. When it comes to manual operable windows, it's of course it's more about statistical models. So for window use based on environmental conditions, and this is often based on temperature, as it's easier to predict than air quality. However, the modeling software has often it's not possible to implement these statistical models within the modeling software, and the manual behavior is often treated as a mechanical system. And it is really an area where there needs further development or further research and information in order to handle efficiently. So with that said, I know some of the topics has been very brief in this webinar, and if you want to know more about the benefits or the hardware, the ventilation strategies, or the energy modeling, you're very welcome to contact me in the future to have a talk about this. And with that said, I want to give the word to Mia.
So just a wrap up on this energy modeling struggles, I've also linked into the chat the tips and tricks that we have created a guide for. As Casper said, it's attached as a handout as well, but there are some descriptions on our website. Casper is definitely able to give you a lot more feedback. But for those of you who also answered earlier, energy modeling and the potential for energy saving is the reason that you're looking at natural ventilation in conjunction to some other benefits, then maybe this handout and the tips and tricks that we have would be useful for you. Our guest in Vancouver does have a question before we hop over to the Q&A. I just want to spend 1 minute on a remaining topic here. It is the system that WindowMaster has to provide. It's a system called NV Embedded. Casper talked a lot about the controllability of actually using some of the systems and control sequences available throughout the year and the seasonal changes, such as winter mode, summer mode, night cooling, pulse and trickle ventilation. That sounds very sophisticated, and it requires that as an engineering team that you have the capabilities to create the intelligent natural ventilation control sequences. And if you'd like to explore an option that WindowMaster has, it is to provide or to use this system called NV Embedded, which is a patented technology. It is a natural ventilation full system that WindowMaster provides, where we would help you specify and then provide and come on site and commission a system that does have all these varying control sequences based off of the seasonal changes using automated windows or vents, such as Casper talked about earlier. It can be two different options. It can be its standalone solution, or it can be part of the BMS system. But do note that WindowMaster does have a package solution that we offer, which is for providing a full automated natural ventilation system. So the intelligent control sequences to algorithmically control a automated window or vent. That is what this system called NV Embedded will help your project to provide. So reach out to me if you have some more questions on NV Embedded, or if you're interested in hearing more about the system and the control sequences that our system does offer, in addition to our motorized window hardware. With that said, we've got 7 minutes left, Casper. That is the end of our webinar today. Thanks for advancing the screen there for me. We're going to hop into the Q&A, so start putting your questions in. I do see we have one question, which we'll start off with. But as you're thinking about your questions as well, we do have some tips and tricks on our website. As you can already see, I've started to post some things in the chat, but I also wanted you to be aware that we do also have some free tools on our website. There is a tool called the Actuator Finder, which, just like the name says, allows you to sit and kind of play with your varying window design to understand what kind of actuator would be best to use. Vanessa, that kind of goes back to your questions about what are the varying window configurations and how did that potentially impact what type of actuator to use, and the operation styles of that actuator. So hop onto our actuator finder on our website. There's also the air change rate calculator, which allows you to sit and to have some assistance on how to calculate the air change rate required in a zone. And then there's a dimensioning tool also to help you dimensionalize what you need in terms of the full natural ventilation system that you're considering for your project. All free tools on our website. I'll link to them all in the chat here. But Casper, while I'm finding the links to those 3 tools, if you will start us off with answering a question from our participant in Vancouver. Sorry if I say your name wrong. I think it's Tikon, says, how does switching from window multi-lock hardware to automated driven reflect on air infiltration rate? Any recommendations to window size and operation?
Yeah, so this question, I think, is about the if adding an actuator to a window will impact the air tightness of the window. And the general answer is no, it will not. The window will still close completely tight. But there is, in terms of recommendation of the window sizes, there are limits for when you need an additional actuator on a window based on the width. So we typically say, maybe you can help me with the amount of inches, Mia. So it's typically when the window is above 1400 millimeters.
So we're looking at 55 inches in the width of a awning or a hopper window.
Yeah, so that's typically the point where you will need to add an extra actuator for different reasons, but for example for the air tightness of the window when it closes.
So no changes to the infiltration rates, sizes. Try to, if you want to be budget friendly, try to keep your awning or your hopper windows at 55 inches or less on the width. If it's a casement window, then the mounting of an actuator will go vertically. So there on a casement window, you want to keep the height at the same, so at or below 55 inches, then you have the most economically possible automated solution, because you would only need, in general, one actuator per window. So there is that to think about. The different heights also give differences in terms of free area. So use the actuator finder also to see how you change the different window dimensions and configuration and what that does to your geometric free area. The actuator finder tool will also help you understand the variances in the geometric free area capable with the current design options that you're looking at for your project. Vanessa, another great question. You say, I would be interested in hearing about the cost of installing actuators being comparable to existing manual windows. That is a fantastic question. So from the perspective of WindowMaster, we do not install any of the window automation hardware. We manufacture and sell the hardware, and then the glazing contractor would be the one responsible, who has typically the scope under a Division 8 for purchasing the hardware from the actuator provider and then getting them purchased, but also installing them. On average, we've seen it takes these glazing contractors, of course, dependent on how well versed they are with automated solutions. But if they have had a little bit of experience, or after they've done a few windows, then they start to understand the installation for the project. And then we've seen on average, it takes them about 3/4 of an hour to an hour to install and the mounting brackets and the actuator and to run the cabling as they need. What their cost is to do that very much depends on the glazing contractor, what kind of hourly rates that they have. So definitely talk to a glazing contractor who you're working with, or potentially ask them to help you on the budgeting side of things to understand the cost of that. And then connect with WindowMaster. We can definitely give you some rough budgeting numbers in terms of what does it cost to actually purchase window automation hardware. So the actuators, the mounting brackets, the motor controller that Casper talked about and showed earlier, these are those 120-volt panels that provide the power and controllability. And then also any kind of override buttons like a rocker or a key switch. And if you need any kind of sensor capability, we can definitely help you in your project. Even if it's not going out to bid, reach out to us and we'll be happy to provide you with some rough estimated costing, so that you can get it also from the source. What does the hardware cost? And of course, do that through a potential contracting glazer, because as your question alludes to, they also will need to tack on the cost of doing the installation and any kind of handling of the actuators, so administrative time. So work with us and a glazing contractor, and then you'll have a nice overview of the scope of the cost of getting hardware for an automated window and the installation. Yeah, so please reach out to me if you need that. You will need an electrician to actually get the low voltage. So the actuators at the window, they are low voltage, but they need to get connected to the power panel, which is a 120-volt power. Yes, so the glazing contractor will typically be responsible for mounting the window automation hardware on the window that they provide in a project. And then it will be typically an electrician who handles from the low voltage cabling at the window and are responsible for running that back to the panel possibly also providing the 120 volt power to the panel themselves and getting all the wires terminated correctly at the panel. So it is you're correct, it's a combined effort of window automation hardware providers, i.e. somebody like WindowMaster, working with a glazing contractor to get the components installed on the operable windows, and then also working with an electrical contractor to run the cabling back to the panel and getting it all set up and terminated correctly at a panel. And then if it's much more sophisticated, it requires BMS integration, or if you're using the whole natural ventilation system, like control sequences like Casper talked about earlier, you also would add on to the layers of working with a controls contractor to work with the integration of the building management system, and or somebody like WindowMaster to provide a control sequence package, such as the system I mentioned, the NV embedded. So depends on what your needs are for the project. We are way over time. Unfortunately, we are at 3 after now. Please submit any questions that the rest of you may have. I'll make sure that we get your answers to you in an email. I'm going to put the dimensioning tool here in the chat, and then we will have to sign off today. And let me do that right now. So that is our webinar today. Thank you so much for tuning in. I appreciate everybody's time. The recording of this will come directly to your email here shortly. Thank you so much for tuning in across North America and for asking and submitting your questions and your participation in the polls today. Casper and we appreciate your time today. So thank you so much, everybody, and please send us any emails with questions that you may have that we weren't able to cover today. And we look forward to hearing from you and hopefully working with you on a project. Thanks, everybody.
Thank you, Mia, and thank you, everyone, for joining.
Bye, Casper. Thank you.
Bye.